with other types of instructions and start with branch instructions. And the purpose of what we will see in this video is to illustrate that there are many different detailed ways to do look seemingly similar things, but the purpose of having all these small versions of instructions is that it can save clock cycles. Obviously, that's what we want. And although the name is reduced instruction set computer, it does not mean reduced number of instructions. It's reduced complexity of instructions. Of the different branch instructions, of course there are conditional and unconditional, but one more is interesting to see. It's a branch which is branch from the program into the operating system. And when this instruction is performed, the CPU will switch into something called supervisor mode and branch directly jump into the kernel. So a user program can call this to branch away from the program, but it is the kernel that branches back. Okay. So, well, I will not talk about the details of this. Feel free to ask me if you want to hear too much of it, more than you desire, I suppose. But we will skip this now. Okay, different forms, and here is another interesting thing. To encode exactly what is desired for the compiler to, for instance, give hints to the CPU whether the compiler thinks a branch will be taken or not. There are many different options in the branch, in the conditional branch instructions. And well, I will not talk about. They are explained to some extent in the book, but I will not spend time on it. And usually, when we write assembler code, I mean with this, then we use something called an extended mnemonic. Mnemonic, that's the acronym of an instruction, the name, so to speak. But there is no special branch not equal instruction. Instead, it's a branch conditional with certain parameters. Okay, and many arithmetic instructions, they can optionally set bits in the condition register field 0 that can then be used to branch. So the purpose of this is that instead of using a separate compare instruction, we can get the result of the comparison from a normal instruction to save one instruction. Okay, and the purpose of this is to show that there are numerous versions with small differences of frequent arithmetic instructions. Okay, I will not go into what they do, but the purpose is to say that by identifying which instructions are usually used, then the IBM researchers and product managers can decide to select some variants that the compiler can exploit to improve the performance. So this is really a hunt for clock cycles. Continue with the definition of what this is it's here, and we can see that there are special versions of the different things. Okay, and okay, let's skip that. And some other logical instructions and more, and the memory access instructions. The B is for byte, H for half word, that's 16 bits, and we can see here the word and the double word. The word is 4 bytes, and the double word is 8 bytes. And there can be, the address can be expressed either as a register plus a sign extended constant, immediate operand, or as the sum of two registers. One interesting thing is the U. It means update. So if we move through an array with a pointer, then this update instruction updates the pointer to the next element. This is not intended to help people writing cryptic C code, but instead to help compilers to make efficient code. And similar for store.